Good afternoon, class. And here's exam 1 review covering from section 1.6 to 3.1. Here's the pledge. Before starting the exam, please read the following pledge aloud. I pledge on my honor that I will neither give nor receive unauthorized assistance during this exam, or for that matter, any other exam. Unauthorized actions include but are not limited to the use of notes, text, graphing calculators, search engines, PowerPoints, or any other resources not explicitly allowed. I want to make sure everybody is clear on that. All right, we're going to look at some of the examples that we've seen before and some of the examples from the exam review that can be found under the modules of Canvas exam 1 module. So here's one example of that. So we want to find the general terms. Sometimes it's pretty complicated. In this case, we notice the sign changes. So we are going to look at 3 parts: the sign, the numerator, and the denominator. So a sub n is the sign, the numerator over the denominator. As far as the sign is concerned, notice it's positive first, then it's negative, positive, negative. It alternates, which means we have to use one of the following, either negative 1 to the power of n or negative 1 to the power of n minus 1. So all you have to do, check. If I use 1 here, I hope you see that you get negative 1. If I use 1 here, I get negative 1 to the power of 0, which is positive 1. Because the first one is positive, that's what you're going to use. Also, negative 1 to the power of n minus 1, negative 1 to the power of n plus 1, they result in the same answer, okay? So in some texts, they may use any of them, okay? The next one, we're going to write the numerators, and we notice we need to add a constant, a distance, a difference, which is fixed at 4. That means we are dealing with the arithmetic sequence. The first term is 6, and the distance, or d, equals. So a sub n is a sub 1 plus n minus 1 times d. We replace the a sub 1, and we replace the d. We are going to distribute here. This becomes 4n minus 4, these two add up. So we get 4n plus 2. We write the denominator is 3, 9, 27, and we notice that 3 times 3 is 9, 9 times 3 is 27. The geometric sequence with the first term being 3, and so is the common ratio. So we are going to go with a sub n equals a sub 1 r to the power of n minus 1. So 3 times 3 to the power of n minus 1, reminding you of this product rule. A to the power of m times a to the power of n is a to the power of m plus n. This one has exponent 1, and these two add up. We get 3 to the power of n. And now we have everything here put it in. We get a sub n equals negative 1 to the power of n minus 1. Fraction bar, the top is 4n plus 2, the bottom is 3 to the power of n. You must check. All you have to do, plug in 1. And if you do that, this becomes positive 1. This becomes 4 times 1 plus 2, 6 over 3 to the power of n is 1, 6/3 or 2. I highly recommend you try number 2, number 3 to make sure we haven't made a mistake. So that's the beauty of math. You can check your book. We want to find the first 5 terms. So a sub n is 2 to the power of n minus 4. We start with 1. 2 to the power of 1 is 2 minus 4 gives us negative 2. The second one, 2 squared, is 4 minus 4 is 0. A sub 3, the third one, 2 cubed is 8 minus 4 equals 4, and the rest of them, and you write out the first 5 terms. Find the first six terms of the recursive sequence where a sub 1 is 1, a sub 2 is 2, and a sub n plus 2 is a sub n plus 1 plus 2 a sub n. So we need to do four more. First and foremost, understand the meaning of this. If you want to find a term, a sub n plus 2, you go to a sub n plus 1. That means you go to the previous one. You grab the one before that. And then this one is before that. You grab the one before that, you multiply it by 2, you add them up. So because I have a sub 1 and a sub 2, the next one is a sub 3. I want this one to be 3. And I hope you recognize before that is a sub 2 and before that is a sub 1. So it's a sub 2 plus 2a sub 1. Or you might say if n plus 2 is 3, that means n must be 1. Either way, a sub 3 becomes a sub 2 plus 2a sub 1. A sub 2 is 2 plus 2 times 1. They add up to 4. So obviously following that, or maybe even looking at this, it might be easier. A sub 4 is a sub 3 plus 2 a sub 2. So a sub 3 is 4 plus 2 times 2 is 4, adds up to 8. I'm going to leave it for you to find the next two terms. And the answer would be 1, 2, 4, 8, 16, and 32. I highly recommend you try. We want to find the limits, and I'm going to remind everybody that limit of r to the power of n as n approaches infinity is 0 if r is between -1 and 1. It is 1 if r is equals 1, and it's infinity if r is larger than 1. Another theorem which is important, the limit of 1 over n to the power of p as n approaches infinity is 0 if p is larger than 0. So how do we find the limits? Plug in first. To find limits, simply plug in the value and observe. So let's plug in. 2 to the power of infinity, r is larger than 1 is infinity, and therefore it diverges. Let's do this one. 2 to the power of minus n. According to the negative exponential rule, a to the power of minus m is 1 over a to the power of m. So 2 to the power of negative infinity equals 1 over 2 to the power of infinity, which makes it 0. They add up to 5, and it converges. Same thing here, plug in. 1 over infinity is 0, following in essence this, and becomes 1. Therefore, it converges. All right. Now we want to take a limit. And as you notice, it's a rational function. So we are looking at a rational function where the variable, in this case, n, is approaching infinity. So if we plug in, we get infinity over infinity. So the technique would be to divide by, because n is approaching infinity. If anything else, that's not the methodology. Divide by highest degree term in the denominator, namely n squared. Dividing by n squared or multiplying by 1 over n squared means the same thing. So you do that to each and every term in the numerator as well as the denominator, and you simplify. Because this one has n as the denominator, this one has n squared, this one has n, this one has n squared, and n is approaching infinity. Each and every one of them goes to 0. So the only thing left is 2 over 5. That's the final answer, everybody. Just in case, in previous courses, such as pre-calculus, college algebra, when you want to find the horizontal asymptote, you could say the degree of the numerator and denominator are the same. If you want to go that route, you have to say the degree of the top and the bottom are the same and they are equal to what number, in this case 2. Therefore, the leading terms take over, and therefore it's the ratio of the leading coefficients 2 over 5. So that justification, if you write it, is acceptable as well. We want to express 0.46 bar as a rational number. So it's a repeating decimal, 0.46, and it repeats. So we have this piece, 0.46. Then we have this piece, 0.0046, and this piece. We can write them in the form of a fraction, add them up, or in the form of a decimal and add them up. Either way, a geometric sequence becomes a geometric series if it's a geometric sequence to begin with, and we notice the first term in the form of a fraction or decimal is 0.46 or 46 over 100. You can simplify it, but let's keep it as that. And because the denominator here is 100 times larger, that means the fraction is 100 times smaller. So R is 1 over 100, or if you go with the decimal 0.01. Because R is between -1 and 1, you can use S sub n equals A over 1 minus R. So plug it in. If you go with the fractional format, 46 over 100 over 1 minus 1 over 100. If you want to go with the decimal, the numerator is 0.46 and the denominator is 1 minus that. This is a complex fraction. If you want to simplify this, you're going to multiply the top and the bottom by 100. So obviously, the top becomes 46. The bottom becomes 100 minus 1, or 46 over 99. If you want to go with the decimal, you have 0.46 in the numerator and 0.99 in the denominator. And if you multiply the top and the bottom by 100, you get the same answer, and we are done. This question shows up in the exam review, 3.16 bar. Notice the bar is at top of one of those. That means 3.1, and then number 6 repeats. That means you're adding this part to this part. This is the part that we are going to work on. And this part, you can write it as a fraction, 6 over 100 plus 6 over 1000 and so forth. Or you write it as a decimal, 0.06, 0.006, and so on. So this is the part that we are going to add up, just like the previous case. And to do so, we recognize this as a geometric sequence. The sum is a geometric series. The first term is this one in the form of a fraction or a decimal, 6 over 100 or 0.06. Of course, this can be simplified into 3 over 50. And notice this is 10 times larger than this. So that means the fraction is 10 times smaller. R is 1 over 10. But if you look at this one, 0.1, because R is between -1 and 1, we are going to use S sub n equals A over 1 minus R. So this is 3.1 plus this part, and this part we're going to go with A. That means 6 over 100 over 1 minus R. That means 1 minus 1 over 10. If we want to go with the fraction, if we want to go with the decimal, then we're going to put 0.06 here, 1 minus 0.1 here. So if you are dealing with a complex fraction, how do you fix it? How do you take it to a simple fraction? You multiply the top and the bottom by 100. So this one remains. When you multiply these two, you get 6. When you multiply these two, you get 100 minus 10. And 6 over 100 minus 10, that means 6 over 90. And now I want to show you the decimal, 0.6 over 1 minus 0.1. The decimal format, everybody, means 0.06 over 0.9. And I hope you see that if you multiply this one and this one by 100, you get the same number, 6 over 90. Now, 6 over 90 simplifies to 2 over 30. And we have 3.1 plus that. We're going to write 3 plus 0.1, which is 1 over 10. Because this has denominator 30, we're going to change this to 30, meaning this changes to 3 over 30. And these two add up to 5 over 30, which is 1 over 6. You can leave it like that. They may want you to represent this as an improper fraction, in which case this means 3 times 6 plus 1, 19 over 6. So it depends on how they want it. Okay, everybody. A doctor prescribes a 100 milligram antibiotic tablets to be taken every 8 hours. Again, this is a time step, extremely important, doesn't enter the equation. Just before each tablet is taken, 30% of the drug present in the preceding time step remains in the body. How much drug is left after the third tablet? Write the expression for Q sub n plus 1 in terms of Q sub n. And of course, first and foremost, understand we're going to change the B to Q. So B sub 0 or Q sub 0 equals A equals 0 because when we deal with patients and medications, that is always 0 to begin with, unless otherwise mentioned. Now, this is the amount that is fixed. Every 8 hours, we give the same constant, the fixed amount C equals 100. What is left in the body before we give the next dose is 30%. That means R equals 0.3. Now, we set up a table. Q sub 1 is 100. The next one, we add 100, and then 30% of that is 30. They add up to 130. The next one, Q sub 3, again, we add 100. Now, 30% of 130 is 39. They add up to 139. To write the expression for Q sub n plus 1, this one we change it to Q. And now we go back to the given. When you write the given, it really makes it nice and easy. So Q sub n plus 1 is R, 0.3 Q sub n plus C, 100. And right now, if you replace the n with 1, 2, 3, you can get the table. Find the formula for Q sub n. We first change the B sub n to Q sub n. And then we go back to the given. Replace the Q sub 0 with 0. Lowercase c with 100. Or here and here and here with 0.3. Of course, 0 times 0.3 to the power of n is 0. This is 0.7. We put it underneath 100. And this is the same as 1,000 over 7 because you're going to multiply the top and the bottom by 10. You don't want to have a decimal in the denominator. Use part C to find Q sub 3. If you want to find Q sub 3, all you have to do, replace the n with number 3. In fact, I highly recommend you replace the n with 1, 2, 3. You get all those 3. This is for you to check it out. I would try 1, 2, as well as 3. What is the limiting value? Let's take a limit. And we're going to use the limit laws. We're going to take this one out. We're going to take a limit of this piece and that piece separately. This is a constant. And the limit of a constant is always itself. And this number, 0.3, is between -1 and 1. And this limit goes to 0. So you get 1,000 over 7 precisely, roughly 142.857. Please don't use decimals unless you're asked. And if you're asked, Make sure you pay attention as to how many. What does it mean? Therefore, regardless of how long the treatment continues, see, every 8 hours we are giving the same amount and we keep on indefinitely. Regardless of how long the treatment continues, the drug concentration will never exceed the limiting value, which is 1000/7 milligrams of antibiotic precisely. You want to find the following limits, reminding you to find the limit, just plug in and observe. If it results in a number, you're done. If the limit results in a 0 over some other number, the answer is 0. If it gives you a number over 0, it's infinity or negative infinity. But in most cases, we end up with some sort of indeterminate form like 0/0, infinity over infinity, or infinity minus infinity. For example, here, you get infinity over infinity. Again, you're dealing with a rational function or expression. Because the variable is approaching infinity, you divide by highest degree term in the denominator, namely t squared, and you simplify. And now you plug in. Everything has the denominator t or t squared goes to 0 because that is the denominator is huge. So you get 0 in the numerator, 1 in the denominator, and this is 0. Again, on purpose, I'm writing the denominator is some number, and it doesn't matter what number as long as it's not 0. The result becomes 0. In this case, again, if you plug in, you get infinity over infinity. Again, you're dealing with a rational expression. So what is the technique? The same technique that was mentioned. Since t is approaching infinity, you divide by highest degree term in the denominator, namely t. And you simplify. Now, nothing else can be simplified, plug in infinity. When you do that, the top, infinity plus a number minus a number makes no difference, is infinity. You divide by 5 or 5,000, it is still infinity. The limit of the square root of x squared plus 1 minus x as x approaches infinity. If you plug in, you get infinity minus infinity. And we are going to use a technique. What technique? Because it involves a square root, we're going to use the conjugate. You recall that the conjugate of a minus b is a plus b. The product is a squared minus b squared. So the conjugate of this is itself, you change this to a plus sign. So you're going to multiply and divide by it. I'm going to extend the fraction bar. The denominator doesn't change. The numerator a minus b, a plus b is a squared. That means square root of x squared plus 1 squared minus x squared. And these two cancel each other. And now if you plug in, infinity and infinity add up to infinity, 1 or any number divided by that equals 0. We want to find the following limit, and the first thing is to plug in. When you plug in, e to the power minus infinity becomes 0. Why is that? According to negative exponential rule, e to the power minus m is 1 over e to the power of m. Therefore, e to the power minus t is 1 over e to the power of t. And for this case, 1 over e to the power of infinity, that means 0. So the answer is 12 over 4 or 3. What about this case? We plug in The numerator becomes infinity, the bottom becomes negative infinity. And although this is not a rational expression, it is a fractional expression. Because t is approaching infinity and because it's a fractional format, you divide by highest value in the denominator, which is e to the power of t, and simplify. When you simplify, you get the limit of 5 over e to the power of t plus 1 over 4 over e to the power of t minus 3. And since t approaches infinity, this one and this one go to 0. So positive 1 over negative 3 is negative 1/3 as the final answer. What about the limit of x squared minus x as x approaches infinity? Plug in. You get infinity minus infinity. Technique. We can factor it. When we do so, each one becomes infinity because infinity times infinity minus 1 and infinity minus 1 is infinity. The answer is infinity. What about this one? You're dealing with a fraction, and more specifically, a rational expression. X is approaching infinity. You plug in, you get infinity over minus infinity. You divide by highest degree term in the denominator, namely x. We are going to simplify everything from the top to the bottom. And now we plug in. So first of all, when we simplify the top, when we divide by x, this becomes x plus 1, 3 over x minus 1. We plug in. Infinity plus 1 or minus 1 makes no difference, is infinity. But what you want to pay attention is that the denominator is 0, minus 1, or negative 1. Division by a negative results in a negative infinity. That's the only thing you want to be careful of, everybody. All right, we have a graph and we want to find a bunch of limits, reminding you that limit exists if one-sided limits are identical. So you have to show work for your exam. This might be an example that because it's a graph, you just read it. You don't have to show work, just to let you know. So we are interested in finding the limit of g of x as x approaches 2. So you locate the 2 along the x-axis and approach it from the left. Then it puts us in this branch. We are approaching this hole, which has a y-coordinate 3. Go back to the x-axis. Now from the right side of 2, we are in this branch moving towards this hole, which has a y-coordinate 1. According to one-sided limits, since they are different, the limit does not exist. Same thing for number 5. We want to find the limit of g of x as x approaches 5, and we do the same thing. We look at one-sided limit. Therefore, we find the 5 along the x-axis, and from the left, we move this way. From the right, we move that way. Both of them are taking us towards this hole, which one has a y-coordinate 2. Therefore, the limit of g of x as x approaches 5 exists and is equal to 2. If we go back to 5 and we want a functional value, you look for the solid point, and the solid point seems to have a y-coordinate of 1.4. So g of 5 is given and it's equal to 1.4. However, it's not equal to the limit. As far as 2 is concerned, there is no solid point. We have no idea what it is. So g of 2 is undefined. Now, that makes both of those points discontinuous. So reminding everybody, according to the continuity definition, limit of f of x as x approaches a equals f of a, that makes it continuous at x equals a. So what's going on at each case? G of x can be continuous at x equals 5. The way it's given, no. But can it be continuous? Yes. Because the limit exists, if we redefine g of 5 to be 2, this can be fixed. This is a type of discontinuity called removable discontinuity. So if we redefine g of 5 and make it equal to the limit, the answer is yes. Then it becomes continuous. So it's fixable. We can fix it. Not a big deal. But what about 2? First of all, g of 2 is not defined. That's not a big deal. What is a big deal? It's a jump. There is nothing we can do to fix it. So this is not fixable. We want to find the limit of R of x as x approaches various numbers, reminding you of the definition of a VA, vertical asymptote. If the limit of f of x as x approaches a, or a from the left to right is negative or positive infinity, then x equals a is a vertical asymptote. So starting with 2, we find number 2 along the x-axis and we approach it from the left and right. Both of them seem to go to negative infinity. Limit of R of x as x approaches 5, we approach 5 from the left and right along the x-axis. So the answer is positive infinity. What about negative 3? Well, from the left side, the limit of R of x as x approaches negative 3 from the left takes us down to negative infinity. Limit of R of x as x approaches minus 3 from the right is a different story, takes us to positive infinity. According to this definition, in this case, x equals 2. In this case, x equals 5. In this case, x equals negative 3. In this case, the same thing, x equals negative 3. Those are the vertical asymptotes. This is how you find vertical asymptotes. And again, because these are graphs, you may not worry about showing work.